For this one, we need to make sure we highlight our reference angles because triangles have 3 and we're only going to refer to 1. And then this is the hypotenuse and the other highlighted one is always adjacent. So this is opposite. SohCahToa. And then these guys are just the reciprocal, so we just have to flip it. So this is going to be 5 over 12, the adjacent side, sorry, 5 over 13. This one is 12 over 13, and this one is 5 over 12. And so to do the cotangent, we have 12 over 5, 13 over 12, and 13 over 5. That's it for that guy.
Let's go that way.
Okay, again, highlighting the angle that we're referencing, which 2 sides make it. And then we're going to label. The hypotenuse is always opposite the 90 degrees. And then this is the adjacent side. This is the opposite. Then we make our little chart. We're looking for the opposite, which is y, and then the hypotenuse is 5. Opposite and hypotenuse is sine, so it's the sine of 28 degrees equals y over 5. Get the y by itself, and then we have y equals 5 sine 28. And then you're going to plug that into your calculator, and then that gives you 2.3. Okay, for this guy, same thing, over and over again. Highlight the reference angle. So in this case, it's this 31 degree one. This is hypotenuse, adjacent, and opposite. So this is 31, this is 18, and x is in the adjacent side. Then we know that's cosine. So cosine of 31 equals x over 18. Get the x by itself by reversing that division. So then we get x equals 18 cosine 31. Plug that into your calculator and you get 15.4. The next problem is super easy, so you shouldn't miss it on the test unless you just forget that our job is to solve for the angle. And what's in front of the angle is the tangent. So you need to undo that tangent. So again, the way we undo that tangent is to reverse it. And the way we reverse it is with the inverse. So theta is going to equal tangent inverse of 3 over 5. So you plug that into your calculator and it says round to the nearest degree, and that's 31 degrees. Same thing here, cosine of theta equals 1/3. The way we reverse that cosine so we can solve for the angle is use cosine inverse. When that happens, the cosine inverse and the cosine cancel out on one side, and then on the other, there's nothing to cancel out. We just got to plug it into the calculator, and that gives me 71 degrees. Okay, so we're going up here. We have to find the measure of angle A. Because it's an angle, we know we're going to be using inverse tangent. So these are the sides that make up angle A. This is the hypotenuse, and this is opposite. No, it's not. The highlighted part is always adjacent, and this is opposite. So we're trying to find A. We know the opposite is 7, and we know the hypotenuse is 11. So then if I take that, I know that's going to be sine. So I'm going to set up my trig ratio. The sine of A equals 7 over 11. Then to isolate the angle, I have to use inverse trig. These cancel. So A equals sine inverse of 7 over 11. And then you're going to plug that into your calculator and get 40 degrees, which just make sure your calculator's in degree mode. Same thing for this guy. We're gonna highlight the angle that we're referencing, and then we're gonna label hypotenuse, adjacent, opposite. So measure of angle A, I know the hypotenuse is 26 and adjacent is 23, which leads me to cosine. So the cosine of A equals 23 over 26. Inverse cosine, because we're solving for an angle. So I get A equals cosine inverse of 23 over 26, which equals 28 degrees. So hopefully we're able to get that. And now we have some word problems here. So this says that the Americans with Disabilities Act, which just makes sure that people in wheelchairs don't get hurt, basically. And it keeps them safe and has laws to make sure that things are built with them in mind. So it says the maximum angle for a wheelchair ramp. So I'm going to draw a ramp just so I have a good idea. Has a 4.76 angle, a maximum angle. It says determine the horizontal distance. So the horizontal distance is left to right. So it's going to be that. And it's needed to accommodate a ramp that goes 2 feet off the ground. So now we have the same setup as before. This is the angle we're referencing. So we can set up our table. This is 4.76 degrees. Adjacent, hypotenuse, opposite. And so that's 2 over x. So that's going to be a tangent. So we're going to have the tangent of 4.76 degrees equals 2 over x. And the x in the denominator isn't really helpful, so we're going to multiply it into the numerator. So that side cancels out. And then from there, we're going to divide out that tangent so that we can get the x by itself. What we do to one side, we do to the other. So then this cancels out right here, and we're just going to plug in 2 divided by the tangent of 46 into our, or not 46, 4.76 into our calculator, and that gives us a horizontal distance of 24 feet. Okay, and then you can see for your test, you will have one where you're solving for a side and one where you're solving for an angle. So just read the directions on rounding. This one said round to the nearest foot. Normally, if we're doing a side, we round to the nearest tenth. But for this one, it says nearest foot, so that's a whole number. For number 9, you have a building right here, and it casts a shadow on the ground. So it's telling you the shadow's on the ground, so keep it on the ground. The building is 24 feet tall, but it's casting a longer shadow. And it says, what is the angle of elevation of the sun at that time today? So just a reminder, that angle of elevation is always from the horizontal going up, and angle of depression would be from the horizontal. So it's always that one. So if I connect and make my triangle, the one that angle I'm going to be interested in is this guy right there, because it's closest to the horizontal. Okay, so that's what they're asking about. So we'll just keep doing the same old, same old. I'm just going to call this theta. You can call it A. This is adjacent because it's highlighted. This is opposite. So this is going to be 24/37. And because I have those two, I'll be using the tangent ratio. Tangent of theta equals 24/37. Solving for an angle, so we need to use inverse to get rid of the tangent in front. Those cancel out, and I just have theta equals tangent inverse of 24/37. So that equals 33 degrees. Alrighty, let's flip this over. So this first one says convert each measure from degrees to radians, and that's where we've used that formula, pi over 180 degrees. The degree symbols cancel out, and just a friendly reminder, when you're multiplying fractions, you multiply tops over bottoms, and then we're going to take this piece and plug it into the calculator, and it's going to tell us that that is 1/6, but we still have the pi, so it's 1/6 of pi or pi over 6. Okay, same thing with the next one, times pi over 180, because those are equivalent places on our circle. And then that's really negative 150. The degrees are going to cancel, putting it in radians, over 180. And then I'm going to plug this piece into my calculator and reduce that. And that gives me negative 5/6. And then I just like to throw the pi in the numerator. And then for this one, it's going to be pi in the denominator because I want it to cancel out. And then 180 in the numerator. And then what I'm going to plug into the calculator is negative 3/4 times 180, and that gives me negative 135. If you're really good at graphing and you forget this ratio right here, then you can always just graph negative 3 pi over 4, and it ends up right there. And you could also notice that this is negative 90 and negative 180, and this is in the middle, so it's just another negative 45, and you could get the same answer if you forget those ratios. And if you're really good at graphing, it's a little harder to do with something with 15, so I'm just going to use the calculator for that. Again, the pi is going in the bottom on this one because I want it to cancel out, and then I just plug 11/15 times 180 into the calculator, and I get 132 degrees. So from there, I'm going to go to the next piece, which is just graphing the angle. So again, just graph. We're not making tables. We're not doing anything. We're not making triangles. So 240 degrees. I know this is 180. And I know this is 270, and it's closer to 270 than it is to the middle or to 180. Negative 405, negatives go in the opposite direction. And so if I go all the way around, this is negative 360, and that's negative 450. Friendly reminder, if you get stuck on counting, just go by 9. So negative 9, 18, 27, 36, 45, and then you can add in the zeros. So this is going to come all the way around and go 45 degrees past. Now we got the radians, and for the radians, we know that this is 0 and this is pi, and that this denominator is 6. So this means we got to cut the semicircle into 6 equal slices. 1, 2, 3, 4, 5, and then here's the 6. So that's the different slices right there. And then we're going to come around and grab the 5th one. And that's it right there. Negative 3 pi over 4. Again, 0, negative pi, and this is 4/4. So I need to cut the bottom half of the graph into fourths, which means that they're in the middle. This is -1, -2, -3, slice -4. And then I'm going to go to the third one because the numerator is -3. That's that. Next part of your test is about finding reference angles. So what you're going to want to do is graph the angle and then figure out what gets it back to the x-axis. And it's always positive. So again, x-axis, always positive. Okay, so 330 degrees is between 270 and 360. It's closer to 360, so I'm going to come around and make sure it gets closer to 360. So this is the angle 330 degrees. If this is 330 and it needs to get back to the x-axis, how many more degrees does it need? 30 degrees. Okay, you can also take 360, the bigger number, and subtract it from 330 and get 30 degrees too. For this one, this is -90, this is -180, gets right here. And we're always connecting it back to the x-axis. So again, this is -135, and the x-axis is at -180. So I would just do 180 minus 35, or you can see that that's just going to take 45 degrees. And again, it's going to be positive because reference angles are always positive. For this one right here, you get pi over 6. So this is 0. This is pi 1/6 is just going to be one slice. And then you connect it to the x-axis. So how many slices did it take to get back to the x-axis? Just one. And again, this was 6 slices, so it's 1 out of 6, or pi over 6. Same as the angle they gave, quadrant 1 angles are always their own reference angle. This is -pi, so we would have this -1, -2, -3, -4, and then we have to start going beyond. So this is -5. So we're going to come up to here and mark it. And then what gets us back to the x-axis? It's only one slice again, so that's pi over 4. We recognized that with radians, if you just put pi over the denominator, you'll get the answer right for our class. Not every radian measure does that, but for our class. Okay, moving up to these guys right here. You are going to skip H. So if you haven't written that and you were like, how do we do that? We're going to learn that next week, so you can just skip that. But for this right here, cosine of 30 degrees, I encourage you to start by always labeling what you're going to find. So then we're going to graph 30 degrees. It's right here. Again, keeping it small. Connect it to the x-axis. Label it. This is small, large. And that reference angle is 30 degrees. So 1/2 √3/2, 1. And then adjacent, opposite, and then hypotenuse. The adjacent one is always on the x-axis. You can also see it because if we highlight the angle of reference, you can see it's adjacent. So it's going to be adjacent over the hypotenuse, so that's just √3/2. Sine of -330, if you look, it actually ends up being the exact same triangle because of where it ends up. So adjacent and opposite. Don't forget that sine is opposite over hypotenuse. So that's 1/2 over 1, which is just 1/2. Tangent of 135. 135 is here. We're going to connect it to the x-axis. You can see that that triangle is actually medium, medium, and our reference angle is 45 degrees. So this is √2/2, but down here, because when I take off from here, I have to go left. That's negative. It's positive on the top because I go up. Tangent is opposite over adjacent, which is, let's label these, adjacent, opposite, root 2 over 2 over negative root 2 over 2, which makes that -1. Secant starts with an S, so its buddy is cosine, S and C, and cosine is A over H, so this is H over A. So then I go to -60 degrees, but always keep in mind it gets connected to the x-axis. That's a small large. 1/2 negative root 3 over 2 and 1. This is going to be the adjacent and then opposite. So the hypotenuse is 1 and the adjacent side is 1/2. So I keep change flip, which makes that 2. Okay, finishing this up right here. We have the sine of 11 pi over 6. So this is 6 out of 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then we get back to 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're going to come all the way around, and there it is. I'm going to clean this up just a little bit here. So our 11th one is right where I have it graphed. Connect it to the x-axis. Label your triangles. It's small, large. And then this is opposite and adjacent. And then because this is sine, this is opposite over hypotenuse. So it's -1/2 over 1, which is -1/2. For the next one, tangent is opposite over adjacent, and it's 8 pi over 3. So 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7, 8. So we're going to go around the circle and come back to this. And then we're going to connect it to the x-axis. This is root 3 over 2. This is -1/2, this is 1, this is op, and this is adjacent. So we're going to have root 3 over 2 over -1/2. So we have to keep change flip. And that gives us root 3 over -1, which is just root 3. And for our last one, we have cosine of -2 pi over 3. So we're going to go in the negative direction. So that's -1, and over here is -2. So we get that. We connect it to the x-axis. So that gives me the sides of -1/2 because I went to the left, and root 3 over 2 because I went down. That's 1. This is going to be adjacent, and this is going to be opposite. Again, just in case you didn't see that, that's because this is our angle that we're referencing here. And then cosine is adjacent over hypotenuse, which is -1/2 over 1, which gives me -1/2. And that's it.